Okay, this is a quadratic equation in standard form because it's written in the form ax squared plus bx plus c equals 0. Okay? So it's not a function, it's an equation. It's got an equal sign in it. Quadratic equation in standard form. Now, this time I have x squared terms and x terms, and those are not like terms. So I can't combine the first two terms, right? So I can't isolate x. I can't point to a single x. I'm going to be stuck here always with two different x's that don't combine, and so I can't isolate. I have to try something different. Okay? What is the something different here? The something different, ideas. What do you think? Yeah, yeah. Okay, well, we're not there yet. Eventually we'll be able to use the quadratic formula. You're right. But we're not to that point yet. Okay? I want to remind you of something first here. Now, I actually, there's a little bit at the end of 5.1 that I didn't want to load you down with. I will eventually give you a couple assignments that deal with this, but there's not much to it. There's one other little concept that you already know how to do really well, and that is this. Let me just grab this guy for a second. Okay, what if I ask you to do something like this? What if I ask you to do, let's say, x plus 3 times x plus 5. And I ask you to multiply that out or expand it out. Does everybody know how to do that? Okay, you guys are familiar with the term FOIL, right? And that's great. You can use FOIL. I want to encourage you to maybe think about it slightly differently, though, just because it's going to help you in Chapter 6 if you think about it a little bit differently. It turns out to be exactly the same process, but I want you to think of it as distributing. When you're multiplying together things like this, when you're multiplying together factors are just things that are being multiplied, right? So I have one factor there and one factor there. If I'm multiplying factors that have multiple terms in them, all I really am doing is distributing. So I'm going to take the first term from the first factor, this x, and I'm going to distribute that to both of the terms in the second factor. Okay? What's that give me?
2x plus 5.
Not 2x. What's x times x?
X squared.
X squared
Plus 5x.
plus x times 5 would be 5x. Good. Okay. What about if I take the 3 now, the other term in the first factor, and distribute that?
3x plus 15.
Yeah, I'm going to get 3x and 15, right? And then all I have to do is combine like terms. Now that really is just foiling, right? If you guys are familiar with the term foiling, what does that mean? Well, F stands for, if I'm looking at these two factors, first term times first term. So the product of the first terms would be x times x is x squared. O is outside terms, or outer terms. So that's an outer term and that's an outer term, right? So x times 5 would be my 5x. I, remember, is inside or inner terms. So did everybody see those are the inside terms? 3 times x is 3x. And then last is just last from the first factor times last from the second factor. So there's my 15. Same thing, right? No big deal. And we get the answer when we do that, after we simplify. I can combine those inside terms to be what?
8x.
8x. So I just get x squared plus 8x plus 15. Okay, so in algebra, we say that process we just did is called expanding. So to go from here over to here is expanding. Expanding is easy. It really is. Piece of cake. Okay, the opposite process is a little more challenging. The opposite process, if we start here and we want to end up here, that's factoring. It's a little bit tougher. Okay. That's what we're going to talk about today. But why? Why? Why would we talk about that? How come that comes up now of all times? We got all this other stuff going on. Well, there's a reason for it, because that's what helps us solve this equation. Right now, if I were able to break this quadratic expression up here on the left side, if I were able to unfoil that and break it up into pieces, that might be really helpful to me. Okay? Well, let's first of all, let's just try that process. So if I want to take this x squared minus x minus 6, and I want to unfoil that. I want to factor that. Let's try this. So we can be a little bit tricky about this, right? We know that the first times the first has to give me x squared, doesn't it? So what are the first two terms of each factor? It's got to be x, right? Now the last times the last would have to multiply to negative 6, right? Because in our example, remember that the x terms are the ones that combine together, but the constant was the last and the x squared was the first, right? Okay, so that helps us a little bit. So then that narrows down our choices, right? Because if the last two numbers have to multiply to negative 6, there's only so many ways we can do that, right? Okay, let's think of those. You tell me, what are all the ways that we can split apart negative 6?
We can put negative 1 in the first parenthesis, and then a plus 6 in the second.
Okay, so one way to do it would be negative 1 times positive 6. What's another way? Okay, I could do negative 2, positive 3. Negative 3, positive 2. Negative 6, positive 1. And that's really it, right? If it's not one of those possibilities, we'll just say it doesn't factor, and we'll call it quits. And there are other ways we can do this, it turns out, right? But factoring is the easiest if it works, you're going to find. Okay, so what we could do then, for now at least, is just try them, see which one works. So if I put negative 1 here and positive 6 there, I can just FOIL those out and see if I get that answer, right? So let's try it. X times x is x squared, first times first, right? So outside would be 6x, inside would be minus x. Is that going to work?
No.
Nope, this one's DQ'd. That's not going to work, right? Okay, so I'll try the next one maybe, all right? Anybody have a suggestion for one of them?
Negative 3, 2.
Negative 3, 2. Let's skip up to that one, how about? Okay, so if I try negative 3, positive 2. Okay, so if I FOIL this out, first times first gives me my x squared, outside gives me plus 2x, right? Inside's going to give me, and then last gives me negative 6. Does that work?
Yes.
Yeah, that works, doesn't it? This stuff adds up to that, doesn't it? Okay, so now, is there a tricky way we could have gone right to that answer? So we already know that the two, we'll call them magic numbers, the two magic numbers have to multiply to c. If we write this in, ax squared plus bx plus c, what's a, b, and c? A is, we're looking at this guy right here. A is 1, b is negative 1, c is, okay, so we know the numbers have to multiply to negative 6. What else? This was the winner, right? What else did they do there that relates to a, b, and c? They add to b. See that? That always works. So that's the trick. We got to find the two magic numbers that multiply to the constant, to c, and add to the coefficient of x, which is always b, right? Once we find those numbers, that's how it's going to factor. Now, I got to remind you here, I got to make sure let's not take this too far. This nice little trick, the way I've defined it, only works when a is equal to 1. When a is not equal to 1, it gets a little bit harder, but also, we're probably not even going to choose to factor when a is not equal to 1. We'll probably choose to use some other trick to solve this equation, because I will give you some others, okay? All right, so let's practice that a little bit. Well, let's go back maybe to the original. Oh, where is the original? This is the original. Okay, so right here. So now we got this thing factored, right? It factored into, we said x minus 3 times x plus 2. Okay, Why is that useful? Well, to get warmed, we have to do some arithmetic now. So I'm going to ask you to multiply some stuff together just to get the brain kind of working here, get it loosened up. So I'm just going to give you a string of numbers. Every time I give you a number, you multiply it by what you already have. Okay, so for example, we'll start off with 2 times 3. So everybody's got 6. Now multiply by -2. So everybody's got -12. Now you can do the rest in your head, but just keep going. Okay, so now we'll multiply by -1, multiply by 3, multiply by 1,974,312.941. Okay, hurry, do this now. Don't write anything down, shoot in your head. Times pi times the square root of 19 out to, just stop it at 4 decimal places. Agree with me? Times 0 equals 0. Okay, all right. Okay, so that's pretty good. You all get, man, you handled that fast. Those are big numbers. So the moral of the story is, I mean, obviously when I multiply by 0, it doesn't matter how hard the other numbers were. Anything times 0 is 0. In fact, we could even say that if I have a product that multiplies to 0, what does that tell me about the factors in the product? There's only one way I can even get 0 when I multiply, and that is I got to multiply by 0, right? Okay, that's huge. That is a great trick. Here's why. Because if I can take this original quadratic expression that's written as a sum of 3 terms, and I can break that down into smaller pieces, a product of smaller pieces, and that product is equal to 0, I know that the only way that can happen is if either the first factor is equal to 0 or the second factor is equal to 0. That's a pretty good trade. If you think about having to analyze the original equation, man, there's no pattern there. It's really difficult to try to somehow magically come up with values of x that are going to make the sum of those 3 terms go to 0. That's really hard. There is no trick for that. And what if the numbers aren't nice, neat integers? If they're decimals or square roots or something, man, you'd never get it. You just never get it that way. You couldn't just try numbers and see which one works. Okay, but if I split it apart, it does work. Makes it easy. Look at the trade we've made here. I'm just going to erase this junk for now so it's not cluttering things up. But look what we're able to do. We're able to trade that one big quadratic equation for 2 nice small linear equations. I've got the small equation x minus 3 equals 0, because that would work, wouldn't it? If x minus 3, if that factor was 0, 0 times something equals 0. Or if x plus 2 equals 0, that would also make the product 0, right? Those are linear. Those are easy. In both of those cases, I can point to a single x and isolate it in one step. What's the answer to this equation?
Yeah.
X minus 3 equals 0 when x equals 3. So that's one solution. What about this one? Got it, right? And when you're solving an equation, remember, all you're trying to do is find all of the values of the variable that make the equation true, that satisfy the equation, right? How could we check and see if we got them right? Plug them in, and they work if we do, I promise you. Okay, isn't that great? Right? That's a good way to do this. So we can just break apart a big equation, a big expression, into a product of smaller factors that are easier equations to solve. Okay? Now there's a way we can even take this process a little bit further and make it simpler to do, to find those numbers. So let's look at a couple examples just to practice this. Okay, what about, okay, we did that one. What about something like that? Okay, let's factor the left side so we can solve this equation. Okay? The 2 magic numbers in this case, I already know that the template has to look like this, doesn't it? The left side is going to break apart like that if it factors. And I know that x's go there and there, right? All I got to do is find the magic numbers. Now we can be smart about this though. We can play a little sign game which really helps us find the numbers. I know that the two numbers have to multiply to positive 12, right? What's the only way the two numbers can multiply to a positive? Two negatives or two positives. They have to be the same sign, right? So that part tells me that they multiply to a positive, tells me that they're either both positive or both negative. But then if they have to add to a positive, they must be positive, right? Does that make sense? If they have to be the same sign but add to a positive, they can only be positive. And so that helps me a little bit. I know they're both positive. And what are the numbers? 4 and 3. And so there's two kinds of questions that you're going to be answering on these assignments in Moodle. One of them is going to be just without the zeros being there equals zeros. Without these being equations, it's going to say just factor that quadratic expression completely. So we're going to break it apart as far as we can. Okay? That would be the answer right there. Now, it doesn't matter the order in which I write those factors. I could write the quantity x plus 3 times the quantity x plus 4 also, and that would be fine. But it has to be entered, broken apart like that, factored. Okay? If I go one step further and answer the other kind of Moodle question, it's going to say find all solutions and separate your solutions with commas or something. I can't remember the exact wording. What are the solutions this time?
-4 and -3.
-4 and -3, not 4 and 3. That's a common mistake. 4 and 3 are the magic numbers, but the solutions are what I get when I set those factors equal to 0 and solve, right? So my solutions are going to be x plus 4 equals 0 when x is -4. Or x plus 3 equals 0 when x is -3. So in Moodle, I would just say, oops, sorry. That's right, yeah. I would just say -4, comma, -3, or -3, comma, -4. Make sense? Okay. So this isn't really that bad, is it? What about that one? This time we're just going to factor it. We're not solve. We're just factor it. Okay, so there's my template. Okay, this time what are the signs of both numbers? Look at that. See if you can tell me what the signs are. I'm hearing positive and negative. Everybody disagree? Here, negative, negative. Okay, which one are we going to go with? If they multiply to a positive, what's that tell you? They got to be same sign, right? And add to a negative, they both must be negative. Okay, I think that's helpful because then all you got to do now is not worry about the signs of the numbers anymore. You're just finding numbers that multiply to 40 and add to 13. You already know they're both negative. So what are they?
-8 and -5.
5 and 8, yeah. Make sense? Are we getting this? Give me a 1 to 5. 5 meaning I'm getting this. 1 meaning whoa. I'm not. Okay. Just flash me a little. I want to kind of see how we're.
-452.
All right. Okay. A little more practice. Okay. Good. Okay. What about one like this?
What?
Okay, this is easier. It's different, so you might think it's harder, but it's much easier. What if I tell you to factor this? Okay, factoring, hard factoring, looks like that. Okay, let's do one more example of those before we go any further. I promised you another example. How about this? X squared plus 2x minus 15. Everybody try that. Don't say it out loud. Just try that on your own. Okay, what can you tell me about the signs of the two magic numbers this time? Opposites. What else? Braxton, get another idea? One's positive, one's negative. Okay, there's even one more thing here that you could probably tell that might be useful. Which one is bigger, the positive or the negative?
The positive.
The positive is, isn't it? Because if they're going to add to a positive, doesn't that mean that when I add the negative and the positive and they kind of cancel, a little bit of positive is left over because the positive number was bigger, right? So I always like to put the biggest one first, so I know now what I'm looking for, right? How much bigger is the positive one?
By
2, right? That's helpful. If the number, these are pretty small numbers, but if they're a really big number, what if I'm trying to find numbers that multiply to negative 284? Those are big numbers. But if I know, for example, that the positive one is 5 bigger than the negative one, that makes it a lot easier. A lot easier, because what I could even do is just pick numbers that are different, where one's 5 bigger than the other, and multiply them and see which ones multiply properly, right? That makes the search, does that make sense? Makes it a little bit easier. If I'm trying to find numbers, I don't know if there are any numbers that are that far apart to multiply to 284, but if I tried, for example, like positive 18 times negative, did I say 2 or 3? I can't remember. It said 2. So positive 18 times negative 16, what am I going to get? I don't know. 256 plus 32 is going to give me, oh wow, 288. So it's close. Pretend it was 288. Okay, that would have been it, right? Okay. If I was a little bit off, what if what if it needed to be a little bigger? Well, I could make each of these one bigger, and that would help me identify those magic numbers if I got a really big product, right? I mean, you kind of have to do it to see what I mean. But okay, so what are my answers then?
5 and 3.
5 and 3, yeah. Plus 5 minus 3. One more, what about this one? X squared minus 4x minus 45. Yeah, well, you're good at this. You guys are getting this down. So that's x. Okay, good. We'll put the big one first. So minus 9 plus 5, right? Magic numbers have to multiply to negative 45, add to negative 4. So those are the numbers that do that. Okay? So that's hard factoring. Now let's get easier. What if I ask you to factor that? Okay, factoring just means breaking apart into the smallest pieces that multiply together, right? I'm going to unmultiply. Well, in this case, I don't have to do anything difficult, but factoring can also mean, instead of unfoiling, it can just mean undistributed. What we always want to do first, before we start to jump into these big complicated ones, is decide, is there something that divides into both of those terms that I can undistribute? Is there something that divides into both 3x and 12? 3 does, right? The number 3 does. Agreed? So I could undistribute a 3. Whoops. You can undistribute a 3, and if I do that, what am I left with? Well, 3 times what, if I distributed to 3, would give me back 3x. X. 3 times what, if I distribute into 3, gives me 12? 4. That's one way to think about it. Another more mathematical, I like that way, but another more mathematical way is this. I can say 3x divided by 3 is what? X, right? 1x. 12 divided by 3 is 4. Factoring out of 3 means I'm just dividing each term by 3 to see what's left over. Okay? Make sense? Okay, try another one. Same idea. Factor out the greatest common factor this time. What's the biggest thing that divides into both 2x squared and 22x?
2.
Okay, 2 is the number part. What about a variable part? Okay, now I want to remind you about a property of variables, or property of exponents, sorry. A to the m times a to the n equals what? What happens if I multiply like bases? Say it again. What do I do to the exponents if I multiply like bases? How?
It'll just be AMN squared. Or
No, not quite. Add them together. Yeah, if you multiply like bases, you add the exponents, right? So that would be a to the m plus n. So for example, x cubed times x squared is x to the fifth, right? Okay, now dividing is real similar. x to the m divided by x to the n is what? Subtract, yeah. If you divide like bases, you subtract the exponents. So for example, x to the 7th over x to the 5th
X to the second.
is x to the 2nd, yeah. And another way you can even think about that is I'm going to cancel 5 of those away from the top, leaving me with 2, right? Okay, everybody with me? Okay? All right, so now maybe that helps.
There's a
So what's the biggest power of x that I could divide away from each of those two terms?
2x.
Just an x, right? I could only divide an x away. Okay, now what am I left with if I do that? There's a couple ways we can kind of, model this in our heads. I can undistribute a 2x. What does that leave me with here? 2x times what? If I redistribute that, it's going to give me a 2x squared. X, right? Because x to the 1 times x to the 1 is x squared plus 11. Okay, how do we know it's an x? Here's another way to sort of visualize that. When I'm factoring out a greatest common factor, I'm really just trying to strip away as much from each term as I can, right? The number part we get. That's just the biggest number that divides into both numbers. But the variable part has to do with the exponents, right? So when I'm factoring out variables, I'm just stripping away the biggest power of x that each of the terms has the power to give me. And the weakest term is the one that's going to limit that process, right? The first term here has x squared. It has a power of 2. X squared, it has that power to give me. But the second one only has an x to the 1, so it can only give away an x, right? So the most that I could strip away from the second one is x to the 1, so I can't strip more than that away from the first one either, because I'm looking for a common factor, the one that they each can give me. Does that make sense? So I can only strip away the power of x that's represented in the weakest of all the terms. Does that make sense? Okay? So, and then if I divide these things, you can also look at it the math way. 2x squared divided by 2x, well, the 2's cancel. X to the 2 over x to the 1 is x, right? 22x divided by my 2x, the x's cancel. 22 over 2 is 11. Right? Okay, another one. So right now, how about this? Let's do what's the greatest common factor? I want to factor that completely. So you got to think of the number part and the variable part, really, right? What goes out front? What's the biggest number that goes into both 15 and 6? 3. Okay, what about the variable part? What's the most I can strip away from those terms? X to the... No. This one could give me up to x to the 7th. This one only gives me x to the 4th. So can I strip away an x to the 4th then? Right? They each, this one can only let me strip away an x to the 4th. This one could give me more, but I'm limited by this one because that's the weaker of the two. So I can undistribute an x to the 4th. What's that leave me with? Well, what goes here? 3 times what is 15? 5. X to the 4th times what power of x is x to the 7th?
3.
Right? Does that make sense? Okay, what about over here? 3 times what is negative 6? And x to the 4th times what power of x is that? Well, I've already got my x to the 4th, right? I already have x to the 4th, I just have the wrong number of them. I got to multiply by negative 2 so I can get 6 of them, negative 6 of them there, right? Make sense?
Mm-hmm.
Okay. Another one. How about this? How about, let's do, Okay, let's factor that one completely. Okay, is there a greatest common factor that I can undistribute? Because that's easy. 2,
2x plus 3.
It's just 2x.
2x, right? I can take an x away from each of those. And here's something else too, and this is going to seem a little strange. I'm going to go ahead because, I shouldn't have done this. Because the leading term, I'm going to change this just a little bit. I don't want to have to deal with this right now. Here, I'm going to just make one small change. Let me do the same thing. Make that a negative and that a negative. That'll help. Okay? All right, so I can take out the number part is what? 2. And you already told me I can take an x out, right? Now, what am I left with if I do that? So from the first term, what's left over? 2x times what is 2x cubed?
1x squared.
That makes sense? X squared? Okay. Okay, what about here? 2x times what is negative 4x? Well, 2 times what is negative 4?
2x.
Negative 2. And x times what is x squared? X. And 2 times what is negative 30? Okay. And then x, so 2x times negative 15 is negative 30x, right? Okay, good. We done? We're done with one step, but can we go further? Remember, if we're factoring completely. This one's done. There's nothing I can do to this one to separate it. It's already taken care of. But what about this guy? I've got 2 factors here. I've got this little one times this big factor that's got 3 terms added together. Okay, that's in the form ax squared plus bx plus c, so we could try to break that apart. Maybe we can, maybe we can't. So let's focus on just this part. Can this one be broken apart into 2 parts? Right, if I just forget about the 2x now and I'm working on factoring the other factor, breaking it apart further, are there magic numbers that multiply to negative 15 and add to negative 2?
Yeah.
What are the signs?
Negative 5.
Negative 5, positive 3, right? So now I'm done. Okay, now that's broken apart all the way, and I know it's broken apart all the way because I'm left with x's to the 1. I can't go any further than that, right? Does that make sense? Okay, now did you see there, I know there's a lot to kind of take in, but really this is about as hard as it gets, just about. What made this a lot easier was factoring out that 2x. You always want to try to factor out the greatest common factor first, and that makes things easier all the time if you can. By taking that 2x out front, we ended up getting something that we're able to deal with using the tricks that we've already talked about, right? Does that make sense? Okay? It's probably good for today, huh?
Yeah.
Okay? All right. All right.